Welcome back to another lesson in MCR3U. Today we'll be looking at the exponent rules, and this will be a review from previous courses that you may have taken as well. So again, when we're looking at exponents, exponents represent repeated multiplication. So here, if you see 5 to the power of 4, it's equal to 5 times 5 times 5 times 5. So 5 times itself 4 times. So if we look at 5 to the power of 4, there's a couple important things to recognize here. This entire thing is called a power. So 5 to the power of 4, it's in its entirety is a power. The 4 is the exponent, and the 5 is the base. So here, if we're evaluating 5 to the power of 4, it would be 5 times 5 times 5 times 5, which would give us 625. So here, when we look at exponents law, we're going to look at 7 different exponents law here. So when we're multiplying powers, so again, multiplying powers with the same base. So that's important. When we're doing these here, they have to be the same base. So for example, we have x to the power of m times x to the power of n. We see that here there's the same base. And when we multiply these exponents, then we can add the powers together. We can add these exponents together. So x to the power, so we keep the base, and we add the exponents. So here it's x to the power of m plus n. When we're dividing powers, so x to the power of m divided by x to the power of n is equal to x to the power of m minus n. So we're subtracting the exponents. So here, again, the base has to be the same. If the base is different, cannot use these exponent laws. If we're looking at power to an exponent, so here, for example, it's x to the power of m to the power of n. So again, x to the power of m in the brackets, we see this as x to the power of m times however many times. So here it's x to the power of m times however many times x to the power of m we have. So here we are multiplying m and n. So here we have x to the power, we keep the base, m times n. So look at zero exponents. So anything to the power of 0 is equal to 1. And here, x here cannot be equal to 0. If we look at a negative exponent, so here a negative exponent, x to the power of, for example, negative m, we can write it as 1 over x to the power of m. So anything that is in the denominator of a fraction can be represented as a negative exponent. As well, if we have a fraction of x over y to the power of negative m, we can flip the fraction and make it a positive exponent. So if we flip the fraction, change the numerator and denominator and flip them, here we have y over x to the power of m. So we're flipping the fraction and making it into a positive exponent. Here, if we look at bracket into exponent, so here, say we have a bx to the power of m. It's important to recognize here that the exponent m needs to apply to all 3 terms that are inside the bracket. So it doesn't just apply to a or b or x, it applies to all 3. And so here, that gives us a to the power of m, b to the power of m and x to the power of m. And so it's important to recognize that if we have constants, we'll use the constants and to the power and the exponents. If you have exponents inside the brackets, you'll use the same exponent rules that we looked at previously. And finally, powers with rational bases. So here, let's say we have x over y to the power of m. Again, the power of m will distribute to both the numerator and the denominator. So that here will give you x to the power of m over y to the power of m. Okay, so let's look at these examples here. So here it says simplify the following expressions. So again, we see here that the base of -2 is the same. -2 to the power 3 times -2 to the power of 2. And so we keep the base and we add the exponents. So here would be 3 plus 2. So -2 to the power of 5 would be our answer. Here we see that we have -3q squared r squared to the power of 3. So we're going to distribute, again, this exponent into all three of the terms. So here we would get -3 to the power of 3 times q squared to the power of 3 and r squared to the power of 3. And so -3 to the power of 3 is -27. Q squared times q squared to the power of 3 would be 2 times 3. So it would be q to the power of 6. And 2 to the power of 3, which would be r to the power of 6. So here our answer is -27 q to the power of 6, r to the power of 6. If we look at C here, so again, you're going to first distribute the 2 into the 3 r, s, and t. 3 r, s, and t. And so here we'll get 2r squared s squared t times 3 squared r squared s squared and t squared. Here, when we're looking at it, we can rewrite it as 2, 2r squared, 2r squared s squared t times 9r squared s squared t squared. So when we're looking at multiplying these, we'll multiply first the constants with each other. We'll multiply, and then each of the bases to each other. So 2 will multiply to 9, which will give us 18. So 2 and 9 will multiply together. That will give us 18. R squared will multiply with each other. Well, R squared and R squared will multiply with each other. And so that will give us R to the power of 4. S squared and S squared will multiply to each other. Give us S to the power of 4. And T and T squared will multiply each other, give us T to the power of 3. So here we have 2 cubed a -2b to the power 4 over 4a to the power 5 b to the power -3. So here we can rewrite this as 2 to the power of 3, a to the power of -2, b to the power of 4 over 2 to the power of 2, which is still 4, a to the power of 5, and b to the power of -3. Here, if we have the base is the same, 2 to the power of 3 divided by 2 to the power of 2, which is 2 to the power of 3 minus 2, that will give us 2. And here we have a, so we can write that actually. So 2 to the power of 3 minus 2, a to the power of negative 2 minus 5, b to the power of 4 minus negative 3. So here we have 2 to the power of 1, a to the power of negative 7, and b to the power of 7. Remember, anything that's a negative exponent, we can write in the denominator. So our final answer will be 2b to the power of 7 over a to the power of 7. Okay, so let's look at here e. So we have 3ab squared to the power over 5a negative 3 to the power of negative 2. Here, again, we can rewrite this. So if we do everything inside the bracket, so remember bed mass, and brackets first, then exponents. So if we do brackets first, 3 over 5, 3 over 5, and here we have a to the power of 1 minus negative 3 times e to the power of 2, and all to the power of negative 2. And so here it equals 3 a to the power of 4 times b to the power of 2 over 5 to the power of negative 2. And remember, if we have a negative exponent here, we can flip the fraction and make that exponent positive. So here will be 5 over 3a to the power of 4, b to the power of 2 to the power of 2. Now we can distribute this exponent into each of the components inside the brackets. So 5 squared will give you 25 over 3 squared, which is 9. A to the power of 4 to the power of 2 is a to the power of 8, and b to the power of 4.